I've started by copying over the tables from the supplemental lab packet for this lab, and I have filled it in with some sample data. These numbers will not be the same as your numbers that you get, but they're for illustration purposes. So I have some sample data for measuring out the mass of fructose in order to make flask A and B. So if I want to find the fructose content of flask A, I would take the mass of fructose, which is in cell B3, and divide by the volume of the solution, which is in cell C3. So that gives me my calculated fructose content for flask A. And notice it gives me several digits. I can make it show more or fewer by going to the Home tab at the top and playing around with these number buttons with the zeros. So if I want it with proper significant figures, since my volume of the solution has 4 significant figures, I will adjust it until I have 4 left. Remember, the zeros on the left are not significant. So I can do the same thing, equals B4 divided by C4, or I can drag this down and have it do the same calculation for me. For flasks C and D, instead of you making them yourself, they have been already made for you, and you just need to copy those numbers from the board, which may or may not be the same as what I have in this sample data. We will also be finding the density of those solutions that you have made. So for flask A, you would need to measure the mass of the empty 50 milliliter beaker that you are using from the center table. And that mass of the empty beaker can be used for all of these mass of the empty beakers. You just need to make sure that it's clean and dry when you make that initial measurement. Then we need to measure the mass of the beaker with the solution in it. So you're putting in 2 milliliters of solution A, measuring that mass, and then adding another 2 to make 4, measuring that mass, adding another 2 to make 6, measuring that mass, adding another 2 to make 8, measuring that mass. But we're not really interested in the mass of the beaker with the solution in it. We're interested in the mass of just the solution, the liquid in the beaker, because we're trying to find the density of the liquid in the beaker. So we need to take the mass of the beaker plus the solution and subtract the mass of the empty beaker. So we'll do equals, and then B11, and then minus. And then to make sure that when I drag it down to make this calculation happen 4 times, to make sure it grabs the right number value, since I want it to use the exact same square each time, I'm going to put some dollar signs next to my cell. So I'm going to say $C $9. So it will definitely choose C9 each time when I drag it down. So I can click on that and drag it down, and it will do B12 minus C9, B13 minus C9, and B14 minus C9. If I click on that, you can see that's what it's doing, B14 minus C9. But to make sure it did that C9 each time, I had to put those dollar signs in there. Now that I have the mass of just the solution, I can find the density of the solution by taking the mass of the solution divided by the volume of the solution. So I do equals C11 divided by A11. So I'm doing mass divided by volume. I hit enter, and it gives me the density of the solution. So that's one of my data points. I want to do it for 4 different data points for each solution. So I'm going to drag that calculation down and have it do the calculation for me. And again, notice it's giving me a bunch of different digits, and I want it to display ideally proper significant figures, although it is keeping the unrounded number in the background. So in this case, my mass of just the solution has 5 significant figures, and my volume, I believe, is actually 3 significant figures. So we would want to round these to 3 significant figures. So we could do the same type of calculation in our next table. So let's see if we just copy and paste this calculation from the first table, what happens. So when I click on my equation bar, it's telling me it's doing B20 minus C9. That would be fine since C9 is the same as C18, which is the same thing as C27. I'm using that same mass of the empty beaker every time. If I really wanted to make sure it was doing it exactly like from the table, I could change C9 to say C18, but it'll give me the same thing. So if I drag that down, it will do that same type of calculation. Notice as my volume is going up, my mass is going up. So when I calculate the density, again, I can just kind of copy and paste that down and it will do that same type of calculation. So it's doing, in this case, C20 divided by A20. And it gives me the density of the solution, which I can drag down to do all 4 calculations. And notice it's rounding to 3 digits after the decimal. But this is a multiplication and division rule kind of problem since we're doing mass divided by volume. I still want 3 significant figures, so I'm going to actually take away one of those digits for that. So now those have 3 significant figures. And again, these volumes are really 2.00, etc. Then I can do the same type of calculation for flask C. Paste that in. And again, right now it's subtracting C18. That number value is the same as in C27, but if I really want to, I can change that. Drag that down. Copy from up here and paste and drag that down. And again, I'm keeping 3 significant figures because my volumes actually have 3 significant figures. And then I can do the same thing for flask D. Copy, paste, drag it down, copy, paste, drag it down. Or I could probably have just selected the whole thing, copy and paste, and that would work as well. So now I have my individual density values for my 4 flasks. But what I really want is the average density for each of my flasks. So we could do equals and then sum and then D11 through D14. Or Excel also has a function for average. So I can do equals, average, parentheses, D11 colon D14, parentheses. And that will give me the average. And again, since it's doing, I'm doing the same type of calculation for all 4 tables, I can copy and paste. And notice it's doing D20 through D23. And then paste for this table. Oops, let's copy that again. Copy, paste, and now it's doing D9 through D32. And then again, copy and paste, and it's doing D38 through D41. So now I have my average densities for my 4 flasks. I also have my fructose content for my 4 flasks, and those two are related. As the fructose content, that is the concentration, goes up, the density also goes up, and it goes up by a certain amount, and we're trying to find that relationship. So what we want to do is make a graph that relates that fructose content to the density for each of our 4 solutions. So for my fructose content, rather than typing the number in, I want to actually link to my calculation. So my calculation was up here, and I want to do equals cell D3 so that it plugs in not just that 0.02604, but that unrounded number that's been hiding in the background. So equals D3 for my fructose content for A. Then for my fructose content for B, that is in cell D4. So I'll do equals D4. That way it uses that unrounded value. And again, I can make it display more or fewer digits. My average densities I just calculated. They're the ones that are under the table. So for flask A, the average density is in cell C15. For flask B, the average density is in cell C24. For flask C, the average density is in cell C33. And for flask D, the average density is in cell C42. Again, I'm typing in the cell letter and number rather than the number value, because this way it links to the unrounded number that I got from my calculations earlier. Once I have all those unrounded numbers put into my table, I can turn this table into a graph. When I'm graphing in Excel, I want whatever I want on my x-axis in the first column and whatever I want on my y-axis in the second column. So I've got my fructose content on my x-axis and my density on my y-axis. So I'm going to select just the data, not my headings. And then I can start to graph it. So I'm going to look across the top and see, I want the Insert tab at the top. And then I want the picture of under charts that has the dots. So I select that, and then I select scatter, and I want the one with just the dots, not the ones with lines drawn in. So I've made my scatter plot with the data from that table. Then I want to right-click on one of the dots and add trend line. I want a linear equation to be fit to my data, and linear is already selected, so I don't need to do anything for that. Then I scroll down and hit display equation on chart and display R-squared value on chart. And that should update. So now it shows my equation and R-squared value. I moved over so I can see those numbers better. And I can update the font size by right-clicking, and then I can change the font. So let's make that bigger. so it's easier to see. So my equation for my line that Excel put in is y equals 0.4138x plus 0.9784. And so that's this dotted line. That's the equation for the dotted line that is being fit to my 4 data points. The r-squared value tells me how well that line fits my data. The best fit would be an r-squared value of 1. So this r-squared value of 0.9087 tells me that it's not a perfect fit. My data is a little bit off compared to strictly linear. So once I have this equation for the line, since I have graphed my fructose content on my x-axis and my density on my y-axis, if I have a number value for density, I could plug that number value in for y and solve for x, which would be the concentration or fructose content of that solution. So I can do that for my unknown solution. When I find the density of that unknown solution, I plug that in for y, and then I solve for x, which would be the concentration of the unknown solution.